Alright guys, so let's go on to the next question from CAT 2017, the second slot. You can pause the video and try solving it and then resume for the solution. So it's a very common question type that we have already discussed in our course also. You can check out the card flashing towards the right hand side corner of the screen right now, or you can check out the link in the description for the same question. Let's see how many different pairs a comma b of positive integers are there such that a is less than equal to b and 1 upon a plus 1 upon b is 1 upon 9. So we start by taking the LCM of a, b and 9 throughout, that is 9ab, and this equation will multiply throughout by 9ab, right? So 1 upon a into 9ab will be 9b plus 1 upon b, this term into 9ab will make it 9a, is equal to 1 upon 9, this term into 9ab is simply ab. Now take the other two terms, take both the terms on the left hand side to the right, you will simply get ab minus 9a minus 9b is equal to 0. And the next step is minus 9 into minus 9 would be plus 81. So we just add 81 to both sides of the equation. So between the first two terms, we can simply take an a common. So we get b minus 9. And between the other two terms, I can take a minus 9 common. It will be b minus 9 is equal to 81 plus 0, which is 81. So now take b minus 9 common, b minus 9 common. What remains is simply a minus 9. A minus 9 into b minus 9 is 81. So finally, it all boils down to finding the number of positive integral solutions for a minus 9 into b minus 9 is equal to 81. The condition is a should be less than or equal to b. So now the left hand side is product of two numbers and right hand side is 81. So let's factorize 81. One possibility is 1 and 81. So you get a as 10 and b as 90. A as 10 and b as 90. This is one possible solution. What if I write 81 as 3 into 27? So a minus 9 will be 3 or a will be 12. B minus 9 is 27. So b is 36. The next possible solution is, let's take both 9 and 9 each. So a minus 9 would be 9, giving you a as 18. And b minus 9 is also 9, giving you b as again 18. Any value you take for a and b further, let's say if I take 27 and 3, then a will be 36 and b will be 12. Well, that's not acceptable because in this question, a is less than or equal to b. So I have only 1, 2 and 3. These three solutions. That's the answer to my question. There are exactly 3 positive integral solutions for a and b in this case.